Thank you very much. Hope you enjoyed the conference. Thank you for being here. I will just start with the first question. How many of you are using Koin in the room? Thanks. A few then. Then let's go. And yeah, I'm Arnaud Giuliani. I'm a French developer, and currently I'm an Android developer at Curve. It's a fintech in London, based in London. And I'm doing some Kotlin open source also. You can follow me on Twitter and Medium. And before digging into some code and stuff like that, perhaps I will tell you more the story about Koin. And the first question here, and this is the first question that many people was asking me about. Yeah, why are you crazy enough to try to write a new dependency injection framework? Yeah. To answer that, let's get back in 2016, and in 2016 we had the first stable version of Kotlin. I was waiting this first stable version to put everything in production because it was tagged on the website, production ready. Then I put Kotlin everywhere I can. And when you begin to write stuff with Kotlin, you clearly feel like a superhero. But finally, there's something in the ecosystem that mainly all the tools that we have here are mainly driven by Java. Not that this is something wrong, but now that we have mainly new superpower to write stuff and interesting stuff, it's, for me, it's getting boring to write such thing like annotation stuff and all the stuff, kind of stuff like that, and code generation. I don't want to write such things like that. Perhaps it's French stuff to go on strike for that, but yeah, finally, with Kotlin, you can even write anything without any DI framework if you want. You can write little things. You have object classes, functions, lazy, delegate. You have reify type. You can do many things by yourself. It's quite really fun to write, but also you will see that, yeah, it's not so good to maintain that every day. And I'm looking a simple solution. Simple, not in the meaning that is simple to something stupid, but clearly for me the simplicity of writing the stuff allow me to write everything I want. Don't want to be vendor locked by any kind of solution and write and lock down my writing of application. And for me, when I looked at many solutions in my Android apps, I didn't find what I was looking for in that time. And clearly, I want something that is oriented for developers, not too much digging into theory or other features. I want something clearly that is simple to read and understand. I'm kind of lazy person. I don't want to read documentation. I just copy-paste snippets, and it has to work. But finally, I feel that when I write something like that in Kotlin, it can be I'm somewhere around something that I want a function of a class. Okay, I can have a link between those two expressions, between the two components here. Okay, and finally, I think that it's just miss a little part to bring the link between those two expressions, a function that link to a function because there. Finally, we can express everything that we are building with just functions. And this is the key concept of Koin. And to help you understand the stuff, the best way to do that is to help you with a real application. And it's about coffee. Developers like coffee. And the best way to do that is the coffee maker app, and to illustrate something with the daggers example here. And you will see that it's not so complex to understand because we just want a coffee maker stuff here. And we will have several parts that we want to inject by constructor and by interface. We have a pump here, the famous thermos hyphen component. And we have a heater, something that heats the water to make your coffee. And what we have here is that we want the coffee maker to make the brew process directly with those two components and directly by their interfaces. And yeah, we can add more link here because we want the thermosiphon to control the water heating stuff. And what we will see here together is that in purely Kotlin style, we will write this stuff, and you will see that it's not so complex to understand. The first thing here, and perhaps the most complex here, is the heater interface. Yeah, three functions, on, off, is hot. And how we write the electric heater component. We have the on, the off, and the is hot. And the on function will print this little stuff on the console. That's it. We have the electric heater that is heating the water, the thermosiphon here that is will just make pump here, okay? And we have a thermosiphon component. We will use constructor injection here, and we will make pumping. That means that we will print the stuff in the console if the heater is okay with that, okay? And finally, we want to write the coffee maker, and the coffee maker is using those two components in the constructor, and then also we make the brew process of it. That means we just use the heater, pumping the stuff, and then we can print that we have our coffee, and that's it. Last part of this exercise is that we need an external component out of those three components of the coffee maker to dig out, to keep out this coffee maker instance, and we want to run this instance, okay? And this is the key question here, how we assemble it, okay? What is Koin? Koin is an iterative DSL to describe what you want in your components. It's a lightweight container. Think something that is just running your functions for you and help retrieve your functions. And we want a simple API to let you write everything you want with your definitions. To begin and to write this exercise, you can just use the Koin core package. That is the main standalone version of the dependency injection framework. And then you can begin to write stuff with that. How we can write definitions here. What we want to do is just to use the Koin DSL to write stuff. And this DSL will compile directly with our code. And here, we use the module functions just to describe the definition that we want. And here, we will write how the definitions that we want to use and how they will interact. And these, we have two kinds of definitions, mainly. And 80% of the time, you will use single as singleton and factory, things that will create instance each time you want to ask for an instance. And that's it. That means that behind this keyword, single or factory, you give a function to describe how you build your instance, and that's it. You are completely free to write anything you want because this is purely Kotlin. How we will do that for our application then? Let's write a module. And let's begin with the electric heater, okay? And that's really simple because we just write single electric heater, okay? We just direct instance in the constructor here. And in Koin, there is no magic. There is no magic, then we don't have to rely on introspection to guess what kind of type you want to deal with that. And then you have to be explicit about the type that you want to search in the Koin registry then. And then I have to explicitly say to Koin that I want a heater here about this definition. Nice. I continue, then I write my thermosiphon here, and the same, I will say that I want a pump. But here, the compiler will say that there's missing something here. We have the constructor, and it's pure Kotlin code here. Then I have to bring the link to say that I want another instance from Koin and give me the heater instance here. And what we do, it just gets. You see that the DSL is kind of really intuitive and it's just rely on 4 keywords. And because Kotlin is smart enough, you don't have to specify the key for that, the type for that. Let's finish to describe our application with the coffee maker. We just want another singleton of that, and then we describe that we have a coffee maker and we need 2 instances and we write it like that. And that's it. Just read 3 lines, a module of the definition. Everything compiles directly with your Kotlin code, and that's it. Mainly, you can also rely on splitting modules definition. And you will see that we can something really simple here, that we don't want import stuff or linking stuff. All is completely dynamic, and you can just run a bunch of modules to run your applications. And later, we will see together that we have also tools to let you verify a bunch of graph definitions. And then you can go run completely dynamic stuff, and you can verify also all the configuration that you've written with Koin. One of the main concepts of Koin also is the Koin component. That is that it's a way to say to you that it's a class that is allowed to use the Koin container directly. Why we need that? Because we want an interface marker to help you understand that you are linking yourself to the Koin API. We want to avoid people to import statically directly all the stuff directly from Koin, because then we open the door to really spaghetti code and you can write anything from anywhere. We don't want that, and we want to help you identify that you are linking yourself to the Koin API. When you write mostly your application in the DSL, you are writing the stuff completely out of Koin. We just use the DSL to call your instance. And then all the components that you are here are completely independent of Koin. When you use the Koin API, then you get access to Inject and get functions extensions that allow you to get any instance of your applications directly. This is extensions that I bring to you for you there in your applications, and we use the reified Kotlin types to guess the type that you want here. And for us, it's really important concept, because there we can bootstrap and integrate any kind of runtime that is using Koin behind that. That means that for us, we can easily bring new stuff for Android, Cato, or other kind of project that is using Kotlin under the hood. And then let's go back to the Coffee Maker app, and we just have to use the Koin component interface here, and we unlock the by inject functions here, and that's it. You have access to your instance. Let's finish with that, and you need to start Koin, to start the container, to run the definitions, and then allow all the other API to run your instance. And for that, from a main, for your main point here, what you have to do is to start Koin. This is the 2.0 way of starting Koin. That is, it's a DSL to let you write what you want in Koin. And then here, we just want modules. You just describe that you are loading the modules. This is the minimal stuff that you have to describe here. And then you can easily run your stuff. You can, if you have several modules, you can just use separately with the comma here. That is the var arg call of the modules. And then here, we can call the coffee app instance and just put run here, and we have our coffee. If we want to respect the exercise here, we have a lazy link here. That means that the header shouldn't be instantiated until we need it. And then how we do that, clearly in pure Kotlin, we won't reinvent the wheel. We just say that we are using Kotlin. And again, the Kotlin lazy definition stuff will help us directly have a lazy definition type here. And then we can use a natural way of dealing with that, is that we are using the delegate side. Let's get back to some Dagger definitions of that, and what you should have to write if you were writing this with Dagger is that you will have to declare your header with a singleton and linking to the pump module. You have the pump module here that binds your thermosiphon definitions, and also you have to declare that your singleton is you have to declare your singleton for the coffee app here. And don't forget also that you have to inject your constructor, okay? And you can also see here that we are using the Dagger type as here. It's not the native Kotlin type, it's the Dagger type that helps you have the stuff, and then we have to wrap it with a lazy delegate expression here. As you have to use the get functions everywhere you are using your heater instance. But then you have your Dagger application. Yeah, just migrate. What else? And then to help you migrate the stuff, here's a way to do that. Just begin to select one little instance, isolated instance of your applications, and we will make the bridge to the Koin to the Dagger world with the Koin component, interfaces. That means that for us, we will begin to write electric heater that we describe this instance here, and from the other code that we are using that is still using Dagger, we will eliminate all the code that is using the heater instance from Dagger, and we will request it directly from Koin by the Koin component interface. And this other instance here, we can also use the delegate like this. It's kind of a Trojan horse, and you begin to use completely Koin directly with that. And you can migrate all the components one by one, and then you are hit with your application. You can find a complete article about that deals into all the details about, and then if you want to go in more details about the coffee maker application migration. Let's go in more details with the Android extensions and all the stuff that we can bring for Android, because then we can create directly instance of the activity and fragments for you directly, because then we have to rely on the lifecycle and all the stuff that you really know about lifecycle in Android. And then for this, we have Koin extensions directly for you that bring for activity fragments service directly extensions as it were directly Koin components. And this out of the box, that means that by just adding this Gradle line, just the Koin Android package here, don't forget to start your Koin application. You can have an Android logger if you want to Koin to log to Android Loadcat, and if you want to reuse your context, your Android context in the dependency injection, don't forget to put this line, whereas it won't find your application instance. But here, in my activity, if I want to use my coffee maker instance, I just use by inject directly. I don't have to put everything to write anything else. If I have to inject the Android context, what I have to do is, for example, here I have a component that needs the Android context. I don't like that because you clearly linking yourself to the Android API. It's clearly less testable as just having stuff that you can just run in the JUnit. But sometimes we have to define components that are using the Android context. In your definitions, what you have to do is use the Android context functions here. And that's it. Mainly, we are dealing with some kind of transient components and stuff that are running around the views and are disappearing and destroying the stuff. And for example, it can, for example, make you think as presenters. And if I have a presenter component that I want to attach to an activity, I will just describe it as a factory. And it will create an instance each time an activity is asking for that. That means that when my activity is getting alive, I will get my presenter instance directly by inject, and then as my activity will only request it only once, it will be okay for me just to use the factory for the presenter in that case. But we have bunch of new stuff for the Android architecture components that let you really write view models directly and easily with you. And then you just have to use the Koin Android view model, just this one. It brings all the Koin Android features and the scope features and the view model features. And it gives you new extensions for the Android view model. That means that it allows me to directly think of my view model with the constructor injection. And you see here that I'm using the view model on the Android class. And in my module, when I have to declare it, what I will use a special keyword. Here is the view model keyword. And I declare my view model, and that's it. I don't have to write my factory and stuff by my hand. All is done for me. And then I just have to resolve the stuff by hand. In my activity, how I retrieve my instance then, I will just use my view model instance directly by view model. I won't use the by inject API because it's a bit more complex than just injecting the instance for you. We have to give the instance from Koin to a factory to the Android factory for you. That's why we need to have a special API for that, but easy to find, as you just say by view model, and you have your view model instance here. You can also use that in the fragment, as you will have your own instance of your view model directly. And there's something here that is really powerful to use is that you can clearly reuse a shared instance of your activity. That means that if you have an activity that is hosting your view model instance, all the fragment and the activity are just sharing the same instance of view model. And this is clearly powerful to let you reuse the same view model between fragments and activity. Testing is quite important for you as you are writing components. If you can't reuse them in test, it will be a very big problem. And that's why we have a Koin test project here. And the first feature that you have to take care is that checking your modules here. Verifying that all your configuration and your strategic configuration, because finally just combining the modules and the stuff like that allow you to have some really interesting combination and easily combine, for example, on offline, online stuff and mocking and real implementation stuff. And checking how I check my modules and how I check the configuration stuff. It will be just a JUnit. That means I can put it in CI or everywhere you want. It's very easy to run then, because what I have to do is just run a Koin application instance with start Koin, my modules or the modules I want, and I just run check modules on that. And it will run every definitions for you, run through the graph, and then if something goes wrong, it will crash and say, I can't retrieve this instance for you. And then it's just 1 second. Then the cost is very interesting because we don't generate anything. We just run through the stuff. You can easily write any modules, and you can have a safety net here to just be sure that you don't miss something. To use it in JUnit, we are hopefully some good extensions for you. And in the current JUnit, you can begin to start an application as usual. But if you want to retrieve your components directly in your application, you can do that with the Koin test interface. And then what you have to do here is that you gain access directly to the by inject, and you can retrieve directly your component from your modules directly in your JUnit. It's really interesting, and we can for you declare mock on the fly. That means that we can use directly the instance that has been declared for you, and we declare instead we declaring a mock, and then we can play with that, and you have a Mockito mock instance here for you. And that's pretty interesting, and it's easy then to test, and don't try to split too much your modules. We can just mock on the fly the stuff that you want, and we can hide easily the stuff. And as everything is lazy, it's just a functions. Finally, all the definitions are just functions. You can just hide the stuff, and we just run the functions that you are using. One of the big topic of the moment is the Koin 2.0 release, and then how it has been about going from 1.0 to 2.0. The main thing about Koin is that the main idea was to keep this simple DSL, because people love that finally with 4 keywords, 5 if you include the view model keyword, but with 5 keywords, you can easily describe anything. And it has been a really interesting goal from that, and people continue to use that. And I would say that with that, you can write 80% of your application. And what is interesting is that when people are just reading configuration, are not familiar with Koin, they just understand completely what we are writing and what we are using. The other stuff is that mainly the API stays pragmatic, and mainly we just give access to the Koin component and get and inject stuff, and we have some other features to help you go in some corner case if you need. But in 1.0, we had some kind of problem of the design here, and we have clearly some bad performance. That means that here, SlowDev is a contributor that helps us by benchmarking the project, and it was clearly awful with such performance. That means that it tried to run several times a project with 500 definitions, and for us, retrieving the instance was around 146 milliseconds. It was too much. Then I completely rewrite the internals for the 2.0, then broken completely the internals, but kept all the ideas and the concept of that. And finally, we are something that is clearly more interesting to use. To touch it, really, what I've done here is that I take the coffee maker app and I compare the code between Koin and Dagger and try to benchmark the stuff in a simple benchmark way, just saying that we are running this code twice and we take the second one just to avoid the cold start effect and some random stuff. And here is the result, that mainly we are clearly really as fast as Dagger in mainly injection configuration. We still are very slow in terms of startup, very slow with some quotes, but here, clearly, Dagger generates all the factory for you. This is the cost of this solution, is that it generates stuff for you and that's ready. For Koin, there's no magic, as we have to read the definitions and we have to help you run this. Some kind of benchmark here, as for example now for running 400 definition, it's around 12 milliseconds, but it's kind of relative and it can depend on the device and the stuff that we have and also what you are writing with your modules. If you have any problem, the advice here is to try to split the modules and try to lazily delegate for later some of the component that takes time. But mainly, the startup of Koin is now really interesting. You can have all the benchmark here about the thermosiphon Dagger stuff and also the GitHub project about the benchmark here. And if you want to upgrade to Koin 2.0 for the people who are using Koin 1.0, the main thing remain in the startup DSL that help us describe completely much better what kind of start we want, because it's clearly a DSL. Then we can bring new concept and we can add new stuff directly at start without breaking all the stuff. And just here is that we just have to rewrite the start Koin function, the old one, with the functions that is declaring the DSL. And mainly after that, all the main conversion and the new import will rely on changing the imports like that. And for example here, if you want to migrate a module, you can just remove the old imports and re-import the stuff. The API are clearly the same. There's some API break, and this has a cause. That means that catching up some real good benchmark here is that finally we allow some DSL module to be too much complex and allow too much weird stuff to be written with the DSL. Now we have completely flat module DSL, because in 1.0 you could try to have some visibility rules and stuff like that, and finally people don't use that. And it clearly complex all the stuff for us. Also, the definition resolution is clearly more performant, and then we rely on some default resolution stuff and qualifiers that will help us write naming for the components. What is interesting is that now we are revamping completely the scope API, and also we are more thinking about context isolation. That means that we are thinking for people who are building solutions that they provide to other developers like SDK, and they want to use Koin without interfering with the other Koin instance from their customers. And now this is possible. That means that you can have your isolated instance of Koin that is running on its own, and then you can have your customer that is using Koin, and there's no problem. You can find everything on that ready for Koin here. It's about the changelog that has been done for the Koin 2.0. I think we have still a bit of time to talk about some features. What is interesting that there's lots of stuff that I would like to share with you, but I don't have time for that. Then I've selected, for example, the scope API and all the stuff that we can do for scopes in Android with Koin 2.0. And then the first question is, what is scope? And the scope is kind of space where you want to resolve some dependency, and then you have this bunch of definitions in that space, and when you don't want to use that space anymore, you just throw this space, and you can't inject those definitions anymore. Those instance, not definitions. That means that let's take something more visual for that, and let's take some time life about the container, your Koin application then. The single definition will live completely with your container, and the factory will be more something one-shot, because then we just give you the instance that we are creating. We don't retain it for you. It's just you that are keeping the instance on your own. And then between Sing and the factory, we want something in the middle. Because then we can have some kind of component that want to survive to multiple views, and then we want to do this easily then. Perhaps you have some kind of user sessions and wallet and stuff like that you have to bring between views and then have to survive for just a bunch of time. But it's not a singleton. The best to think about that is to think about boxes then. And then I think that finally scope, it's like just a box. You put the stuff in, and then when you don't want this box anymore, just throw it away. How I've write it with Koin is that in your module, you just write scope, that you will define a structure of your definition. We are giving a name to this structure, okay? We have the name function here that we give a qualifier. And then we just say that this session scope will have the session data definition inside. And then what I do then is that I create an instance of this box. Here is my session 1 instance, okay? I create it, and then from the session 1 object, I can retrieve anything from that. And all the instances are kept in my session 1 instance, and that's it. And when you don't want it, you can close it, and everything is it's blown away for you. With this, what is really interesting is that finally we can have some bunch of extensions for Android relative to the scope. And here we are making some extension relative to the Android lifecycle and bridged it to the Koin scope mechanism. I was mentioning that we are using the name function to give qualifiers because it can be powerful to give a type instead of a string when you are naming stuff, because then it will be easier to bind stuff related to an instance like my activity here. And by writing a scope like that, I said that, for example, I have a definition that is here a presenter. And then what I can do here is that in my activity, instead of using the by inject directly, that is using the global box to take the idea of box, we are using the current scope inject here. And the current scope, it's an extension that we bring here. We bring a property for you, and we are bridging completely the lifecycle of your activity with that. And we create a scope related to your activity, and we give you for that. Then with current scope property, everything is ready out of the box, and you can inject directly your instance. It will follow the life cycle, okay? And that means that when my activity will be destroyed, the scope instance will be destroyed also. It won't match as a view model because the view model can survive to, it's more techy than that as we have the factory. But it can be interesting, for example, if you want to share your presenter among several components like activity and presenters and fragments, then with a scope, you can deliver something like that. And for example here, let's take in the activity that I want to share it with my fragment above here. And what I will do is that I can access my parent activity scope and then presenter directly like that. That means I can say activity.current scope, and I have access to the current scope on the apparent activity. If you want to access it by a lazy delegate injection, the best is to write it like that with a lazy delegate expression wrapper, and you can put this expression directly top of your class. If you don't do that, you can have a problem with a null pointer exception with the activity because your fragment is not yet attached to your activity, and then scratch. You're getting a null pointer exception. Yeah, that's it. Almost the end of the talk. I hope you enjoy some of the stuff that we saw together. Just some takeaway about you, that if you want to bring Koin to your project, the current version here is 2.1.2.01 then. And then if you want just to run the core features, if you are just using core pure Kotlin functions, you can just use the core package. If you want to use some of the basic Android features, just the buy, inject, and the get functions, you just have these functions. If you want to use the scope with the Android feature, use the Android scope. And if you use the Android view model, use this package. It brings, by inheritance, it brings all the package below. And don't forget to use the Koin test package to test everything for you. For those who didn't use yet Koin, here's a few tips to help you start. We have some getting started projects. These little projects are hosted on GitHub, and you can find a really little playground to help you just kickstart using Koin, and then using all the components that you want. And you can quick start with simple Android app, architecture components and stuff like that. We have also have some Cato applications and other bunch of little tutorials then. And you will see that in less than 5 minutes, you can just play with Koin and just enjoy the stuff. We have the website with a quick reference to the stuff. And one of the main advice is to say, just add it step by step. Try to keep your writing small. And don't forget to check your modules. One of the feedback of people using Koin is that now they are discovering how they can write again their application without any locking, or I would say that with more expression of Kotlin, how they want to build the application. They feel a bit more free because they just write expression, a function of what they want to build. And finally, keep everything simple because Koin is made for that. Don't try to make a super power plan for that. If you have any problem, Stack Overflow, GitHub, Slack, and for Slack, we are on the Kotlin Slack. There's a Koin channel where there are few people. You can ask directly some question here, and feel free to try on Stack Overflow and GitHub if you feel that there's some problem on the project. You can follow the project on Twitter, on Medium, and the most important thing is that we need your feedback, because without your feedback, we couldn't be there. We couldn't have growth like that, and keeping this aspect of Koin is a simple dependency injection framework for you. I just want to thank all the early adopters, the contributors, and all the user community that help maintain the project. And I think that the project is now more than 3,600 stars on GitHub. It's really cool to have that. And if you like Koin, yeah, don't spread the word, and you can go on the website for that. Just a website, and that's it for me. Thank you very much. Perhaps we have time. Yeah, we have time for a question. Here.
Hi. First of all, great job. It's really awesome. My question is that do you have any solutions to support multi-bindings, Dagger style? So binding into sets and maps of identical objects, or is it not in scope in this framework?
Okay, if I understand your question is about adding more than one type to a definition then. Is you want
Yes,
you
yes.
want
So
to
like in a Dagger multi-binding, you are
yeah, yeah.
not providing a single, say,
I didn't
uh,
show
co-
that, but you can do that. We have a bind keyword. That means when you write single with your expression, you can have bind and the class, and they give you an extra class of your definition. The things to keep in mind, it won't be, as we call that, the primary type of your definition. And it will be a secondary type. That means that if you are looking in your definition and you have multiple definitions that, for example, let's say that we have a service interface and you have a bunch of definitions that implement a service interface.
yes, that kind of like a plugin structure, and
Exactly.
I want to inject different plugins
We
which all implement the same interface.
We will not use directly the get functions, but in Koin you have a bind and you give two types directly in unfed, and you say this is the desired target type and the original type of the definition, and you can inject directly the type that you want directly.
Okay, thanks.
Hello, my question is, there is a possibility to import one module in other?
No.
No, okay.
There is no feature like that. To be honest, at the beginning, we begin to thought about that because we see that all the other frameworks are trying to have some kind of import and stuff like that. But finally, in your application, you just write my modules is just a list of many modules, and that's it. And finally, because we can't verify your stuff on the compilation and everything is done on runtime, we don't make the imports then, because finally it has not been a feature request from the community.
Okay, thank you.
Welcome.
Can I have multiple Koin instances in one application?
Yeah. It's what I call the isolated instance. That means that you can have really isolated instance. The cost of that is that you have the main instance that is set up in the global context, and then you have your API, and you can have your inject and get directly in the main extensions. If you isolate an instance, you will have to override the Koin component interface to use. There's a function that is getCoin, and then these functions is, I would say, the location of your Koin instance. And you just have to run a Koin instance. You don't use the start Koin, but Koin application function. You have a local instance that is not referred by any Koin component in the Koin component interface, and you make a new your own Koin component interface that is using your own Koin component instance directly by overriding the getCoin functions. I don't know if it's clear.
Yeah, good enough.
You can find some reference on the website if you want.
Okay, thank you.
The isolated stuff. Thanks.
A second question. The providers, are they evaluated lazily for singletons?
Sorry again?
You have shown us factory and single
Yeah.
functions. Is the lambda evaluated lazy, or is it eager?
Yeah, it's functions. It's a Kotlin function expression that finally, when we run the stuff, we don't know a part of the type, but we pass by inferred parameter type that we don't know really what we are doing here. That's why to verify your graph, we have to run through all your graph and seeing that we are running the stuff, and when we run in one function, we are running to other function and we are reaching the good instance or not.
So basically, when I create a Koin instance, all my providers will be first evaluated.
Yeah, it's completely lazy.
Okay, thank you.
But you can also create instance at start if you want to keep some of the instance that pre-created at your start. You can have in the modules you can have some parameters, and you have the created on start parameter, and you say create those instant on start, and when you start Koin, it will create the first instant that you ask for that. Then you have lazy stuff. By default, we are lazy, but also if you want, you can pre-create the stuff for you also.
Okay, I have another question. I understand that you wanted to design this on purpose without annotation processing. But this also means that the classes that you inject became aware of the injection framework. So you are actually writing Koin-related code into your classes, which are to be injected. So don't you plan to add the kind of module which simply uses the standard inject annotation and just enough annotation processing so you can write your classes and your Koin injection framework separately? Yeah, I don't know if it's clear.
I've talked already about this topic with many people, and the main thing is that to keep you clear, I would say most clean out of the framework is you will have to write mainly all your stuff in the DSL, because then you don't use the Koin API in your components. You have to just write the call of your constructor directly in the DSL, and that's it. You don't have the Koin API inside your classes. But when we are retrieving it, it's like Dagger. You are finally using Dagger inject stuff and initiating the stuff in your class locally to have and request your factory just behind the
Yes, actually, I mean, so usually when we use Dagger, we end up referring to Dagger annotations anyway, but it is, at least in theory, possible to annotate my classes only with Java inject and write DI framework agnostic classes and write the DI setup separately.
Have you already changed of DI framework with that?
Sorry?
Have you already changed of DI framework with just the @inject annotation?
No. I'm just talking about. I mean, in theory, I'm just asking because I mean that might be just a kind of barrier to switching from one framework to another. It would be just easier if you can. I mean, if it would be possible to support that. Okay, I'm just switching over. I'm just putting in a parallel DI framework implementation, and let's see how it performs without actually rewriting your whole code before giving it a try.
We don't, the target is not to go there and to go about annotation processing. And for now, people are supporting it that way, to go clearly in the opposite way of all the annotated processing stuff. And because then it's just easy, and finally all your code just compiled with your code for you. And you will clearly see the gain in terms of performance about the compilation for every day. For me, for example, I have some Dagger project at Curve. It takes several minutes to compile. It's kind of hell. And when we are going to, we are making some dynamic architecture with Koin, and then the Koin projects just compile like that. And yeah, for your question about migrating, I think that you will have to deal with that about the @inject annotation. It's not the plan for now, I would say, for this year, about dealing with that @inject stuff.
Okay, thank you very much.
Thanks, Arnaud, for the great presentation. You can ask him questions later.
Sure.
But yeah, so now we are running out of time. The fireside chat is already started on the main track. That's the first thing. And also thank you for all who joined the Android track today here. It was amazing to have you. And yeah, one more important thing, there will be a party starting at 6:30, and you have to keep your badges because it will allow you to enter, and it will be here in this building, actually on top of this building. And yeah, Arnaud, thanks again.
Thank you very much.